Welcome back at C squared. In this lesson we will talk about parallel and perpendicular lines. We're gonna start with parallel lines, and parallel lines are those lines that do not intersect. Non-vertical parallel lines have the same slope, and you can see on this picture I have line A and B. If you wanna check the slope, they will have the same slope, and the same for lines C and D. C and D are vertical lines. Vertical lines are always parallel lines. The slope of vertical line, if you remember, is undefined. Now let's take a look to this first example I have with the picture below and identify the parallel lines. Justify your answer. So we're going to start with each line. I'm going to start with line A, this one. And I want to see the slope, so I can get any 2 points. I guess I'm gonna take this one, which is the closest, and this one. And this is the slope triangle. And we go one down, one right. So how much is the slope of that line? When you go one down, one right. So 1 over 1, and it's gonna be negative. So it's going to be -1. Let's go to line B. Line B, again, I'm going to try to get 2 points, and the first one I see is this one, and I guess this one here. This is the slope triangle. Let's count the rise, 1, 2, 3, and the run, 1, 2. So the line B has a slope of 3 over 2. It is going up from left to right, so it stays positive. Let's go to line C, which is right here. 2 points. This is going to be 1. This is going to be the second one. And we notice we have something very similar over previous line, line A. The line C, 1 down, 1 right. Going down from left to right, so it's going to be -1. So in this moment we know line A and line C are parallel lines. They do not intersect, and by the way, this is the sign for parallel lines if you've never seen before. Let's go to the next line, line D. Line D is a vertical line. The slope is undefined. Let's go to line E, this one, and I can see 2 points. One is here and one is here. So again, the slope triangle, and we notice the rise is 3, 1, 2, 3. The run is 2, 1, 2. So the slope of line E is going to be 3 over 2. Is going up from left to right, so it stays positive. So in this moment, we notice 3 halves and 3 halves. 3 over 2 and 3 over 2, so the line B and E are parallel lines. We have one more here, line F, which is a vertical line. The slope of line F is undefined. So D and F are parallel lines. Vertical lines are always parallel, and we have 2 horizontal lines. I did not label, but we'll label them now, H and J. I'll say like that. And the slope of H and the slope of G are 0. Horizontal line have a slope of 0. So these 2 lines are also parallel lines. Let's see this example. Now we have equation given to us, and we need to identify the parallel line, and we need to justify our answer. First of all, let's start with this form, which is called the slope-intercept form. This M is the slope. So for the line A, I can really see very fast that M is 2. For line B, what will be that M? That will be 3 over 2. For line C, what will be that M? That will be -1 over 2. So far we were able to identify these three slopes very fast. But what about N, T, and P? You notice these three have different forms. They are in the standard form, so we really need to solve for y. But instead of solving 3 times for y, I'm gonna use this form and I'm gonna solve for y here by subtracting ax first, and then divide by b. And now I have the standard form, the slope-intercept form, I'm sorry, using these letters. This is the slope. So if I get a and b in my equation, the coefficient in the standard form, I can write the slope. What do I mean? Let's take a look. Line N. If you take a look, a is 3, b is, be careful here, negative 2. So I'm going to have this negative, which comes from negative a over b, and then a is 3 and b is negative 2. The double negative cancel out, so we stay with positive 3 halves, not 3 over 3. The slope of line N is 3 over 2. And now I can see 3 over 2 here, 3 over 2 here. So line B and N are parallel lines. Let's take a look to line T. Using the same approach, I'm going to have a negative from this negative, and A over B. A is 1, the invisible one, let me call it like that, and B is 2. So we have negative 1 over 2, nothing to simplify. But what do we notice here? These two slopes are the same, so line C and T are parallel lines. And we have a last line, line P. I'm going to use the same strategy, negative A over B. Negative A is 4, B is negative 2. 4 over negative 2. The double negative cancel out, and we have 4 over 2, which is 2. We notice the slope of line P and the slope of line A are the same, and that means A and P are parallel lines. And the next example, we're going to write an equation in slope-intercept form for the line passing through negative 2 and 4 and parallel to the graph of y equals 2x minus 3. So we have two lines. The line 1 has the equation y equals 2x minus 3. For that reason, I'm going to look to this equation and I'm going to get the slope of this line, which is this guy, the number 2. Let me call this M1. Then I can move to the second line. The second line, what do we know? We know that it's parallel with the first line. So which means the second line has a slope of 2, the same like this one, and it goes through the point negative 2 and 4. So now it's simply finding the equation of a line that has this slope of 2 and goes through negative 2 and 4. And I'm going to use the point slope form. Y minus y1 equals m times x minus x1. So we're going to have y minus, this is x1, this is y1, 4 equals m, that is the 2x minus x1 negative 2. Let's simplify the double negative inside of the parentheses. So that will be 2 times the quantity x plus 2. And since we need a slope-intercept form, distributive property, so we have y minus 4 equals 2 times x, that is 2x, and 2 times 2 is 4. And the last step, add 4. So we have y equals 2x plus 8. This is the equation of the line that is parallel of y equals to x minus 3 and goes to negative 2 and 4. Here on the right side I have a grid, and I want you to see in fact what we have done here graphically. So this line y equals 2x minus 3, I'm going to go to negative 3, the y-intercept, I'm going 2 up, 1 right. I can follow this pattern to get more points, just to be accurate, and this is the line. Of course you may want to use a ruler if it's possible. This is the given line, and for the second line we know the point is negative 2 and 4, negative 2 and 4, and he has the same slope of 2, so I can get some points like this. Unfortunately I cannot go up, but you notice now, if you have a graph paper that is larger than what I have on the screen, you'll notice the y-intercept should be somewhere up here, like a negative, like a positive 8. So this is a graphical way to see what we did in this problem. Let's move to the next example. Write an equation in slope-intercept form of the line that passed through the point negative 2, negative 3, and is parallel to the graph x plus 2y equal 6. So we have the line 1, which has this equation. First of all, we need to solve for y to get the slope, or we can use the shortcut. I did it in the previous examples. So I'm going to subtract x. Let's say we're going to use this technique and then divide by 2. So we have y equals negative 1 over 2x plus 6 over 2, which we can simplify, but we really don't want to do that here. What we need is this negative 1/2. This is the slope of the first line. The slope of the second line, line 2, is going to be the same. And it goes to the point negative 2 and negative 3. So we're going to get y minus y1, that is the point slope form, if you remember, equals m times x minus x1. So in this case you have y minus negative 3 equals m negative 1/2 x minus negative 2. So let's simplify the multiple sign we have. We have y plus 3 on the left side, and on the right side we have x plus 2. And since we need the slope intercept form, I'm going to keep it like this. And I'm going to do the distributive property. Y plus 3 equals negative 1 over 2x. And then we have negative 1 over 2 times 2. Negative 1 over 2 times 2. That will be negative 1. And the last step, I'm going to subtract 3 on both sides. So I have y equals negative 1 over 2x minus 4. And this is the equation of the line that is parallel x plus 2y equals 6 and goes through negative 2 and negative 3. Again, we can look to a little bit to a graphical approach. This line here, I can graph it going to negative 4 and then going 1 up, 2 left to get that negative slope. Okay, this is the second line. And let's take a look to the first line, and I'm going to use this form. We have a y-intercept of 3, 6 over 2 is 3, and the same slope of negative 1/2. Again, multiple points following the same pattern. And you notice now these two are the lines in this problem. My second part of the lesson will be about perpendicular line. The perpendicular line are the line that do intersect. However, they create right angles. And I have some example here. You see this one. These two lines create a right angle. These two lines create a right angle. And these two lines create a right angle. 90 degree, if you do not know what right angle means. And you see I mark it with a box. The slope of non-vertical perpendicular lines are opposite reciprocal, or you can hear negative reciprocal. Either way is correct. Okay, so if you go and check the slope of this line and this line, you will see they are opposite reciprocal. The same for this one and this one. The slope are going to be negative reciprocal. And for the last case, A and D, vertical line undefined, horizontal line 0, they are in fact, how we call them, opposite reciprocal. Well, let's see this example. Use the picture below and identify the perpendicular line. So let's start with line A. The slope of line A will be, let's get 2 points. So I say, let's start with this one, and I think this one will be good. This is the slope triangle. 1, 2, 1, 2, 3, 4, 5. So rise was 2, run was 5. It's going down from left to right, so it's negative 2 over 5. Let's take a look to line B, which is this one. Line B, I will say this is 1 point, and then I can get another one here, and it looks like the rise is 2, 1, 2, the run is 1, 2, 3. So 2 over 3, the line is going down, so negative 2 over 3 is the slope of line B. Let's take a look to line C. This line C is a vertical line, the slope is undefined. The line D, this one. So let's see if we can get 2 points. Like we can get this one, and I do not have another one. That is interesting. So let's move on, even though I think if you take a look, A and D are the one that are perpendicular, but again I don't get another point, unfortunately, and I really don't see how to find that, but I will say that the slope of that line should be 5/2 if you get the second point. Okay, so I will say A is perpendicular. That's the sign for perpendicular for D, on D. Okay, so I apologize. The line D, we cannot really get the slope graphically, and there is no other way here. But let's go to line E. Line E, this one is a horizontal line, the slope is 0. So whenever you get a horizontal and a vertical line, they are perpendicular. So in this case, C perpendicular on E. And we have one last, which is F. I hope on this one we can read the slope, not like in line D. So I'm looking, this is a good point, and this is a good point. And the rise is 1, 2, 3, the run is 1, 2. So we have 3 over 2 is going up from left to right, so it's positive. So now we're looking and we notice these two are what we call negative reciprocal or opposite reciprocal, like I call them. So B is perpendicular on F. My next example will be this one, where we have equation and we need to identify perpendicular line. So very fast we can get the slope for line A. The slope is 3. Remember, here we use y equals mx plus b, where m is the slope. For line B, the slope is 3 over 5. And for line M, the slope is -2/3. And line N, T and P, again, let's do it one more time just to be sure we know how to do it. I'm gonna solve for y in this form. So again, I have this -a/b. This is the one you really need. So if you can remember this, you don't really need to solve like I did here. Well, let's see here. The slope of line N will be -a/b. A it's 5, b it's 3. So -5/3. So now we notice these two lines, line B and N, the slope are opposite or negative reciprocal. B and N are perpendicular lines. Let's go to line T, the slope of line T. This is A, this is B, so we have negative. A is 3, B is -2, so the double negative cancel out. So we have 3 halves. 3 halves and -2/3 are negative reciprocal. So the line M and T are perpendicular lines. And we have line P. Again, I'm going to use -a/b. A it's 2, B it's 6, so we end up with -1/3. This one and this one are negative reciprocal, opposite reciprocal. So line A and P are perpendicular. My next example will be about writing an equation in slope-intercept form for the line that passed through -2 and 4 and is perpendicular to the graph of y equals 2x minus 3. Okay, so first of all, let me show you something graphically. I'm going to go backwards just to see the things a little bit different. So this line, 2x minus 3, so go to this -3, go to up 1, right? And yes, I'm gonna follow the pattern just to get more points and get accurate. Okay, so this is the given line. We need another line that is the second line that is perpendicular on this one and goes through -2 and 4. -2 and 4, and this is the point you're going to ask. Remember, we have to get these two and get the negative reciprocal. That will be -1/2, this one. So my feeling is that the equation of the red line is y equal -1/2x plus 3. I'm gonna do the algebra now and see if that is correct. Okay, right angle here. So let's start with line 1, which has the equation y equals 2x minus 3. The slope is 2, let me call it m1. Now let's go to line 2, and you notice I switched the color. Line 2 is gonna have the same slope, and it's gonna, no, I'm sorry, it's gonna have a negative reciprocal slope because we're talking about perpendicular lines, right? So like in this case, I will say do the reciprocal 1/2 and then change the sign. Do that in your head or write it down on the paper. So the slope is -1/2 and it goes to the point -2 and 4. Okay, so we're gonna have the point slope form. Okay, so we're gonna have y minus 4. y minus 4 equals m negative 1/2 x minus negative 2. So because we have this double negative on the right side inside of the parentheses, let's simplify that. X minus negative 2 becomes x plus 2. Now we need the slope intercept form, so I will do distributive property y minus 4 equals, so we have negative 1 over 2x and negative 1 over 2 times 2, negative 1 over 2 times 2, that is negative 1. And I'm gonna do the last step, plus 4. And we have the equation y equals negative 1 over 2x plus 3. Yeah, which is the equation of this line? This is line 2, the red one, this is the line 1. Okay, I just switched the color. But you see the algebraic and the graphical way in this case. And in any case, it should give you the same answer. The only problem, the graphical way sometimes can get difficult to read the y-intercept. Let's take a look to the next example. Write an equation in slope-intercept form for the line that passes through negative 2, negative 3, and is perpendicular to the graph of x plus 2y equals 6. So let's do kind of the same thing. Approach it graphically first. I'm gonna make x is 0, so y will be 3. If I make y is 0, x will be 6. So you see, I use the intercepts. Then I think I can see this pattern in this case. I was kind of lucky here. This is the line 1 given to us. And now we have the second line, negative 2 and negative 3, negative 2 and negative 3 right here. And this one is going to have a slope of 2. The negative reciprocal of, I'm sorry, the positive to the slope, the negative reciprocal of negative 1/2. This is the line. And again, we are kind of lucky in this case. Like I said, sometimes you can be lucky and we can really see the equation if you want for this line 2. Line 2 is y equals 2x plus 1. Let's see if the graphical way gave us the same thing. So let me be consistent now. I'm going to start with line 1. The equation is x plus 2y equals 6. I'm going to solve for y to get the slope. Of course, you can use the shortcut. I use it in this lesson. And I have y equals negative 1 over 2x plus 6 over 2. Again, what I need is this negative 1/2. This is the slope of the first line. So now I can go to the second line, line 2. The slope of this second line is going to be the negative or the opposite reciprocal. So let's flip this guy. That's his reciprocal, and then change the sign. Okay, so it's a positive 2. So we have the slope of the second line as positive 2, and the point that goes through is negative 2 and negative 3. You know by now what I'm going to use. Y minus y1 equals m times x minus x1. So I'm going to have y minus negative 3 equals m equals to x minus negative 2. Let's first simplify the multiple sign. On the left side we have y plus 3. On the right side we have 2 times the quantity x plus 2. We need a slope-intercept form, so this derivative property y plus 3 equals 2x plus 4, and the last step, subtract 3. And we have y equals 2x, positive 4 minus 3, positive 1, which you notice is this red line in the picture. And that's it. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.